Welcome back. This is Mr. Hassan's Maths channel. I'm going to now answer question number 8 from the October-November 2023 paper 1, variant 2 from the Cambridge 9709 pure mathematics paper. Here we have a question about functions again. It says functions f and g are defined by f of x equals x plus a squared minus a for x is less than or equal to negative a. And g of x is 2x minus 1, for x is an element of all real numbers, where a is a positive constant. Find an expression for the inverse of the function f. So what we'll do is we'll say let y equal our function f of x, which means therefore we can write y equals x plus a squared minus a. Now when we find the inverse function, what I like to do first is swap the x and the y around. So instead of y, I'm going to write x. Instead of x, I'm going to write y. And now I'm going to make the subject of the formula the y. I'm going to make the y the subject of the formula, and then that will be the form of my inverse. So I'm going to add a to both sides. And then I'm going to take the square root of both sides. Now, for now, I'm going to write plus or minus square root. And then when I write it as a function, I will then decide what to do because I can't have both of them. I'm going to subtract a from both sides. So I end up with y equals negative a plus or minus the square root of x plus a. Okay, so now for the inverse function, I'm going to choose whether I'm going to take the positive or negative square root. I can't have both of them. Otherwise, I'll have something that is like this, which is not a function. Function has to be something which is either 1-to-1 or many to one. Okay, so if the function has a positive negative square root, it's going to be something which is 1 to many. Okay, it can't be like that. So as we know that the original function has been restricted for values of x less than negative a. And we can see that x equals negative a is the x coordinate of the vertex. The vertex of this is going to be, this is a quadratic. This form is a quadratic, completed the square. The vertex is going to be minus a minus a. Okay, so a is a positive constant, so it's going to be somewhere down here. That's going to be the vertex. And it's been restricted to x values less than the vertex. So it's going to be on this side, it's been restricted. So because it's left of the vertex, we're going to take the negative square root. So we're going to take the negative square root. So our answer is minus a minus the negative, or take minus the square root of x plus a. Not plus the square root of x plus a, minus the square root of x plus a, because we're taking what's to the left of the vertex. If it was x is greater than or equal to negative a, then we would use the positive square root. Okay, because when you're restricted to what's to the left of the vertex, you use the negative square root. To the right of the vertex, you use the positive square root for the inverse function. Okay, so there's the answer to part A. Part B, it says state the domain of the inverse function. Now, the domain of the inverse function is the range of the original function. So the domain of the inverse function is the range of f. Is a range of f. And we can see from what I've just sketched up here that the range of the original function is going to be from this point here. As we said, the lowest point is minus a. It's going to be from minus a upwards. It continues on this side forever. So it's going to be, the range is y is greater than or equal to negative a. So we can say the range of the inverse function, okay, the domain of the inverse function is the range of the function f. The range of the function f is y is greater than or equal to minus a. Therefore, the domain of the inverse function, because it's domain, we're going to write it in terms of x. X is greater than or equal to negative a. And then it says state the range of the inverse function. Okay. The range of f. That's right. That's what we drew here. That's right. Sorry, I just got a bit confused there. Yeah, that's correct. State the range of the inverse function. Now, the range of the inverse function is the domain of the original function, which we already told is x is less than or equal to a, but because we're looking for range, the range of the inverse function is written as y. We say y is less than or equal to negative a. So that's the range of the inverse function, and that's the domain of the inverse function. Okay, the domain of the inverse is the same as the range of the original. The range of the inverse is the same as the domain of the original in terms of the values. But when you write domain, you have to write x. When you write range, you have to write y, because domain is the x values and range is the y values. Okay, so there's the answer to part B, 1 and 2. Now for answer to part 3, it says, given that a equals 7 over 2, solve the equation g f of x equals 0. So now we know a equals 7 over 2. We can now say the function f with that value is x plus 7 over 2 squared minus 7 over 2. And for the domain, x is less than negative 7 over 2. Okay, so that's the domain of this function. That's the function now. So we got to solve the equation g f of x equals 0. G of f of x equals 0. So what happens is you've got to substitute inside function g what function f of x is. Okay, so instead of the x in g, we're going to write f of x. We'll have 2 times f of x minus 1 equals 0. Okay, 2 times f of x minus 1 equals 0. All right, so now when we solve this, we end up with 2 times f of x equals 1. So f of x is equal to a half. Okay, so now I've got to take the function x plus 7 over 2 squared minus 7 over 2, and I have to make it equal to a half. Okay, I have to equate that to a half now and solve this equation. So I'm going to add 7 over 2 to both sides. So I have x plus 7 over 2 squared equals a half plus 7 over 2, which is 8 over 2, which is 4. So you have x plus 7 over 2 squared is equal to 4. So now we got to take the square root of both sides. We have x plus 7 over 2 is going to be plus or minus 2. Plus or minus 2. Okay. And now we can we can subtract 7 over 2 from both sides. So we end up with, that's 2 is like 4 over 2. I'll write it like that for now. So we have minus 7 over 2 plus 4 over 2. So x can either be minus 7 over 2 plus 4 over 2, which is going to be minus 3 over 2. Or x can be minus 7 over 2 minus 4 over 2, which is minus 11 over 2. Now, if we look at our domain, okay, we can't use x equals minus 3 over 2 because our domain for function f, okay, our domain for function f, what can go into it, okay, the domain of function f is x is less than or equal to negative 7 over 2, okay, and so therefore we can say x is equal to negative 3 over 2. It's not within that domain. This is like minus 1.5. That's minus 3.5. Our domain starts from minus 7 over 2 and goes that way. Minus 3.5 and goes that way. X equals 3 over 2. Negative 3 over 2 is over here. It's not in our domain. But minus 11 over 2, that's like minus 5.5. That's okay. That's within our domain. So we're going to only accept the answer x equals negative 11 over 2 because x equals minus 3 over 2 cannot be part of the domain of function f. Okay, so it cannot be part of the domain of function f because the function f only starts from x is minus 7 over 2. Therefore, x equals minus 3 over 2 cannot be a solution. So we've got to get rid of this solution and only choose that solution. And there's the answer to part C of this question. Is there a part D? Let's have a look. No, there's no part D. Okay, so that concludes this question number 8 from the October-November 2023 Pure Mathematics P1 paper from Cambridge 9709. Other questions from this particular paper can be found in the playlist that will appear in this area over here at the end of the video. Other questions from the topic of functions can be found in the functions playlist, which will appear over here towards the end of the video. And you can also see my work. Well, I guess that's enough for that. You can subscribe to my channel by clicking on this link, and you can watch a video here which will tell you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.